So this last question is just a 2 by 2, and this would be a good example of something I would have you do all the way through on a final exam, because it's only a 2 by 2. I would expect you to be able to find the eigenvalues of a 2 by 2 without problem, and the eigenvectors associated with it. So I'm giving them to you here. Okay, so you could try it, but I'm giving you the eigenvalues and eigenvectors. And then, so A says to diagonalize. So when you're asked to diagonalize, all you're asked to do is to find AP equals PD. So you just need to find D and P. You don't need to do anything more than that. If I say and check, then you would actually do the multiplication and show that they're equal. But to diagonalize is just to find P and D. So that's all that's asking. So what is D and P? We already have the eigenvalues. We put them in either order, so we'll just go in the order they're up here. 2 first, and the -1 in the other diagonal, zeros everywhere else, so that would be your diagonal matrix. And then in the same order, we make P like that. So that's A. That's it. Although it took a while to get there because you had to find the eigenvalues and eigenvectors, right? Part B says find A to the 5th. So that's what you would write down. A to the 5th is P, D to the 5th, P inverse. So what do we need to do in order to actually calculate this? Yeah, and also we need to find the inverse of P. So P inverse 1 over 2 minus a -1. Switch the main diagonal and change the sign of the other. So find the inverse. The inverse of a 2 by 2 is just that formula that it's not very hard to find. And you could check that. P times P inverse. I wouldn't even put the 1/3 in. Right, that's how you would check your inverse. Just multiply them. I just put the 1/3, I just left it in front instead of putting it as a fraction, and then just put it back in when I got 3's down the diagonal. Multiply by 1/3, you get your identity. Okay, so that's our check. So now back over here, if we want to find A to the 5th, we take P, D to the 5th, so D is a 2 and a -1, so 2 to the 5th, 0, 0, -1 to the 5th. And P inverse, which we just found. I didn't leave room for my 1/3, so you could put the 1/3 in or take it out to the front. So here's our inverse. If you put it in, it would look like this, I guess. And now you multiply. So to multiply 3 matrices, you multiply the first 2, and then that answer by the next one. You can multiply these 2 first, and then that one, but this has to be in front. You have to keep them in the same order, is all. So you could take that 1/3 right out to the front. That was our properties of multiplication when we did them. And 2 to the 5th is what? 2 times 2 to the 5th plus 0 is 2 to the 6th. 1. 2 to the 6 is 64 minus 1. 64 plus 2, 66. 32 plus 1. And 32 minus 2. Now that was only 8 of the 5. Writing out 5 matrices wouldn't be too bad if you're going to multiply 3 anyway and find an inverse. But something like 8 of the 10, or something higher than that would certainly be more, much quicker. Okay, now what about part C? So this has to be P in some rearrangement or multiple of the eigenvalue vectors. So let's just write down P. This was for eigenvalue 2, and this one was for eigenvalue -1. And now we're given a Q, which has to be either multiples of the eigenvectors or rearranged. So which was this one? 1, -1. Isn't it the same as that with the opposite sign? So it's just multiplied by -1, and that's okay, it's a multiple. So this would be -1. The same value, don't change it. And this is 2 times that? Yeah, so this is for 2, don't change it, don't multiply them. And so Q inverse AQ, without finding Q inverse or anything like that, is D, but with the rearrangement, so. Now, if I didn't rearrange it, but I did multiply them, it would still be the same as D, the original D. And that's it for that. Questions? Okay. So that's the end of 3.5. So you can do the questions for 3.4 and 3.5 now, if you didn't try them yet, the eigenvalues and eigenvectors. And we will start the next section now.